All right, so this next part might seem a bit weird to you, but what we're going to do is that just to show you how Node works, is that we're immediately going to start coding up our linked list, or a bit of it anyway, just to show you how it works, or at least to show you the node. Because the linked list and the node, they're intertwined. We can't really talk about one without the other. In fact, the node depends on the linked list. And as a result, we're going to create what's called an inner class. A class within a class, which is going to look very complicated and scary, but it's, swear to God, it's not. It's not actually complicated and scary. You might tell yourself it's complicated and scary, but it's not. What we're going to do right over here is we're going to write private class, or private static class. Ooh, that's really weird. Node E. Not really anything you have to remember, but essentially what we're doing is we're saying that this class is private. It doesn't really exist. You know, it can't be accessed outside of this file. Okay, that's the first thing. So that's good because we don't want people. Nodes are kind of internal linked lists. They live off of linked lists. A node by itself doesn't really have meaning, right? There's no point in having a node, as you'll see, just by itself. It only has a purpose inside of a linked list, hence being a private class. Now that static just simply means that it doesn't need to refer to a linked list. It doesn't need to know anything about linked list in order to do what it needs to do. Okay, so this is actually going to look a heck of a lot like the box class that we wrote when we were working generics. So a node holds the memory location of an item. That's simple enough. I'm not going to bother making it private. Why? Because that way because my linked list class should be able to see it. And then it's going to have a node E node, specifically next. Now this is where a lot of students have initial difficulty, and I'm with you. I had initial difficulty with this concept, but it makes sense, right? Because remember, the node doesn't actually store anything. It doesn't actually store an item. This E over here, right, it's some kind of class type. And that means that if it's a node that holds an integer, this integer, it doesn't actually store an integer. It stores the memory location of that integer. If it stores a string, it stores the memory location of that string. Similarly, this next, it doesn't store a node inside it. It's not a Russian nesting doll kind of situation, although that would be cool. Remember, this is the memory location. This next stores the memory location of another node. It stores the memory location of another node, and Java automatically just translates that memory location into something for you, right? If you're coming from C, it's kind of weird. But instead, this means rather than manually having to change memory locations to variables or into types, Java's automatically doing it for you. So that's all we really need. I'm going to create, and I'm going to diverge with the book and how we on the constructor. I like to make my constructor like this: public node E. We just write our class normally like this. Let's see. Oh, we don't need the node over there. Public node, it takes in an item, right? And then we say this dot item is equal to the item that was passed in. And we'll handle the node dot this next variable as need be, right? The book does it slightly differently. They like to have other... Oops. How do we get to this slide? I did not want to be at these slides. My keyboard isn't like responding to those kind of things. Interesting. Or do, oh, right, it's because it's oh, because I'm already in a presentation. Interesting. Okay, that explains a lot. So, that's what a node looks like. It has the memory location of another node. The book does it slightly differently. They have a constructor that automatically takes in the next node. I like to set it manually just to reinforce the point that happens. Okay? So it indicates that we're not going to bother referencing our outer class. We're not going to be bothering the linked list. Now, why don't I just make a public node class? The reason is because when we make trees, we're going to also have another node class. Nodes are very common. So when creating these linked type data structures, and I just don't want one implementations node getting confused with another type of implementations node, right? This way, a linked list knows when it's creating a node, it's creating its own node, right? So how does this work? Well, the way this works is that basically in the linked list, we're going to have the head of the list, which is the memory location of the first item. Okay? So each node contains a memory location of the next node, which contains the memory location of the next node, which contains the memory location of the next node. And the final node in the list, the next node is null. It has no memory location. So once we know we get to the end of the list when we see next is equal to null. All right? And they also contain the memory locations of the items in them. Now, typically, we see these simplified as rather than having the we simplify these. We just don't put the boxes in there. We just draw arrows to indicate what the next node is, right? But this stores the memory location. This guy stores the memory location of this guy stores the memory location of this guy stores the memory location of this guy. All right. So this is the way essentially a linked list looks.